Well, hello, friends. Welcome to Unit 4, Lesson 1. We are going to take a look at trigonometry now. And our first lesson in trig is just around limits of particular trig functions, okay? We do need to take a couple of seconds to review a few items from 30-1, make sure you're comfortable with all of that. And then we're going to look at just some specific limits today that we're going to use for the rest of the chapter, okay? Okay, so first note, we don't use degrees whatsoever at any point in time with calculus, okay? So you want to get your calculator into radian mode and you want to leave it in radian mode, okay? For those of you who have like the Casio scientific calculators, you want to press mode twice, and then that'll give you an option of 1 is degree, 2 is radian, and 3 is gradient. So press 2. You'll see a little R appear on your little screen. For other models, look for the mode button. Usually if you just keep pressing the mode button, the angle options will come up. Or look for a button that says DRG. Often it says DRG with a little arrow beside it. That switches from degrees to radians to gradients. Okay, so just take a look for those guys. If you can't find it on your scientific calculator, take a picture and send it to me or Google it, because Google is very, very helpful. Okay, but you need to be in radians. Okay, now the first thing we're going to do is we need to review the unit circle together. Okay, now if you need a little bit of a refresher, I'm going to go through this fairly quick. I'm going to build the unit circle, but it's meant as a refresher. Okay, if you need to go a little further in depth, the link that you see here on your screen will take you to my 30-1 YouTube lesson on the unit circle, and I go through it much slower and much more in-depth there, okay? So if you need a refresher or you happen to be a student who's taking 31 and 30-1 concurrently, maybe you haven't got to the unit circle yet, you're definitely going to want to take a look at that video, okay? If you can't get the link to work, just Google it. Google solves everything. Okay, so here we go. We're going to build the unit circle. And just like I do in class, in a 30-1 class, I build the unit circle by going around it 3 times, okay? We don't need anything about degree measures here, so what I'm looking for is the radian measure, and I'm looking for the coordinate pair, okay? So first time, I just look at the axis, so we know that this is 0 and 2 pi. Over to the other end, I know that that's pi. So vertically up, I know that that has to be halfway between 0 and pi, so that'd be pi over 2. And then vertically down, I have to be halfway between pi and 2 pi, so I'd be 3 pi over 2. Okay, and then my coordinate points for that would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, second go around, I'm looking at my pi over 4, or if you're still sort of thinking in degrees, which I don't want you to, but it's my 45-degree lines. Okay, so when I add those in, I'm essentially just going up pi over 4 each time. So I go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, and I just reduce that as I go. So pi over 4, 2 pi over 4 is already there, 3 pi over 4, 4 pi over 4 is already there, 5 pi over 4, 6 pi over 4 is already there, and then 7 pi over 4. Okay, now the coordinate point here is root 2 over 2 comma root 2 over 2. If you don't remember how we got that, we built a special triangle and we knew that it was a 45, 45, 90 degree triangle. We knew the ratio for 45, 45, 90 degree triangle was 1, 1, root 2. Then I went to put it into the unit circle, so I had to divide everything by root 2 in order to make the hypotenuse 1. Okay, again, if that doesn't sound familiar, go to the slower paced version of the unit circle. Make sure you get a good understanding of this. The coordinate on the other side is going to be the same, just we take into account the negativity. X is negative in that coordinate. Down in the third quadrant, both are negative, and then in the fourth quadrant, just Y is negative. Okay. Okay, I am going to hide my big fat head for a second, just in case I don't know exactly what I'd be hiding there. So I will just shut me down for a minute while you get all this. Then that was the second go around of the unit circle. The last go around is going to do my pi over 6s, okay, which essentially gives me 1 on either side of the pi over 4s. And again, I'm just going to count up pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. As I do that though, so I'm counting everything, I'm just ignoring the pi over 4 lines. But as I do that, I reduce along the way. So pi over 6, 2 pi over 6 reduces to pi over 3. 3 pi over 6 is already there, it reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 reduces to, or doesn't reduce, sorry, I got carried away there. 6 pi over 6 reduces to pi. 7 pi over 6 doesn't reduce. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. And then we go 10 pi over 6 reduces to 5 pi over 3, and 11 pi over 6 doesn't reduce, okay? Then the coordinate pairs, again, we get the coordinate pair by creating a special triangle. They happen to both be a 30, 60, 90 degree triangle here, just orientated differently. We know that the ratio for 30, 60, 90 degree triangle was 1 root 3, 2. Then we divide everything by 2 so that we fit it into the unit circle, and we get root 3 over 2 comma 1/2. The pi over 3 will be the same thing, just flipped because the orientation has changed. Okay, I think this is an opportune time to bring my head back. Then in the other quadrants, it's the same guys, just with the negativity involved. So if you look at this, all the over 3s will get the same coordinate, and all the over 6s will get the same coordinate. Okay, so that was a very quick review of the unit circle. Again, my intent with that quick review was only for you to say, oh yeah, I remember doing this. I can totally build this. If what just happened has now left you like, then go back and take a look at the full-on lesson on the unit circle, okay? Because I don't want it to cause stress. But it is something you need to be comfortable with. You need to be able to build it and get some of these ratios, okay? All right, so now we're gonna take a look at some limits. And the first one we're gonna look at is the limit of sine x as x approaches 0. So I've given you the graph of sine of x, and we're going to approach 0 from the left on the graph, and we're gonna approach 0 from the right on the graph and see if they approach the same thing. Approaching 0 from the left, the limit would approach sorry, approaching, 0 from the left, the limit would approach 0. Approaching 0 from the right, the limit would still be approaching 0. Okay, and so the limit on the left equals the limit on the right. And so the limit as x approaches 0 of sine of x is 0. That was the first one. See? Piece of cake. Okay, second one, we're going to take a look at the limit of cos of x as x approaches 0. So again, I'm going to approach from the left and from the right. So approaching from the left, I'm approaching 0 from the left, I would be approaching 1. Approaching 0 from the right, I would be approaching 1. And so the limit on the left equals the limit on the right. The limit of cos of x as x approaches 0 is 1. Okay? I started you off with two very easy ones. And we're not going to do a whole lot of work on them today because they're pretty straightforward. Okay, here's where we're going to spend a little bit of time. Very important in calculus is the limit as x approaches 0 of sine x over x. Now, I've shown you the graph of sine x over x, and we are going to use a table to approach this limit. Now, we can't. One thing I need you to understand is even though it looks like it's there is no point at 0, right? Because I can't put 0 in for x. I get sine of 0 divided by 0, and I can't divide by 0. So there's a discontinuity there that the graph is just not showing, okay? So because I can't do direct substitution, I need to approach this from the left and from the right. And so I would like you to fill in the tables that are in your book. I'll give you a second, or you're going to pause me. You're going to figure out what these are and then come back to me, okay? Welcome back. You should have gotten these numbers, and you'll see that as I'm approaching from the left and as I'm approaching from the right, the limit of sine x over x is 1, okay? So from this, we conclude that the limit of sine x over x as x approaches 0 is 1, even though f of x is undefined at x equals 0. In fact, for any multiple angle, the limit of sine kx over kx will always be 1, okay? And so what we're going to play with for a little bit today as we get comfortable is trying to make our stuff look like this so we can solve other limits, okay? Okay. So here we go. Let me just take that ink off. Okay, so we have the limit of sine x over 4x as x approaches 0. Now that doesn't look exactly like I just showed you. So we have to do a little bit of thinking. We know the limit of sine x over x. Well, what's the purpose of the 4 then? Really, that 4 is just a coefficient. This is like 1/4 in front of sine x over x. So I'm just going to rewrite the way this looks. Okay, I haven't actually changed anything. I just pulled that 4 to the front so that I could look at it more as a coefficient. That's going to give me this sine x over x that I need. Now, we already know from our extensive work in limits that this coefficient can now come to the front, right? It actually doesn't affect the limit itself. It'll be 1/4 times whatever that limit is, okay? So whether I go the limit of 1/4 times that, or whether I pull the coefficient into the front and go 1/4 times the limit of sine x over x, I get the same answer. That's what I mean by it doesn't affect it, okay? Where I put it doesn't affect it. Okay, so let's put that to the front, and then I can say the limit of sine x over x is 1. So I end up with 1/4 times 1, which will just be 1/4. Okay. Now, I went right from here to here, and I have a note coming up here just to be warned about specificity. There will be some profs you have in university who are going to want to see you write that as 1 before concluding that it's 1/4, okay? I'm a little bit more relaxed about stuff like that, but just, I don't want you to get to university and say, oh, Hill never told me that. I'm telling you that now, okay? There are certain profs who will be much more on you about how specific your communication is. Okay. So limit of negative sine 3x over x as x approaches 0. Okay. Well, the negative in front of the sign doesn't really bother me because that could be just a coefficient, right? I could just pull -1 to the front. But the 3x inside sign bothers me right now. I can't do that unless it's a 3x on the bottom. Okay. Well, okay, let's make a 3x on the bottom. How do I make a 3x on the bottom? I'd have to multiply x by 3. I can do that as long as whatever I do to the bottom, I do to the top. If I do the same thing to the bottom and the top, I'm not changing mathematically that fraction. So I'm just going to multiply everything by 3/3. Now, take a look at what I did here. At the same time, I pulled that -1 to the front. Okay, so I pulled the -1 to the front. That's a coefficient. And then I multiplied this by 3/3. That's going to give me the 3x that I want right there. And then this 3 will also just get pulled as a coefficient in the front. And then I'm going to have the limit as x approaches 0 of sine 3x over 3x, which is nice to me, right? As long as it says sine kx over kx, that will equal 1. Okay, so I'm looking at that. I'm going to bring that 3 to the front. And then I know that my answer will be -3. Okay. Awesome. Okay, just let me, whoops, I don't know what happened there. Let me get the ink off. Okay, so now the limit of sine 2x over 3x as x approaches 0. Again, like there's nothing I can really do inside here, right? I can't get in there. So that's not the purpose of my life at the moment. The purpose of my life at the moment is I need to make that 3x become a 2x so that it says sine of 2x over 2x. That's going to be nice to me. Okay, well, how do I do that? How do I take a 3 and turn it into a 2? I multiply it by 2/3. Okay, so I just need to multiply both the top and the bottom by 2 over 3. Okay, so I multiply both the top and the bottom by 2 over 3. That's going to give me my 2x on the bottom that I want. And then I have 2/3 sine of 2x over 2x. The 2/3 will come to the front as a coefficient. And I know that the limit as x approaches 0 of sine 2x over 2x will be 1. And then 1 times 2/3 gives me my 2/3. That's my answer. Okay. Okay. What about the limit of 1 minus cos squared x over x squared, where x is approaching 0? Well, I haven't talked to you about a limit that looks like this at all. The only limit I talked to you about was sine x over x. So your first instinct here needs to be, can I make 1 minus cos squared x turn into sine x? And the answer is yes, it's a Pythagorean identity. By the way, if I just stressed you out because you're like, I don't remember any of these, I will give you the 30-1 formula sheet for trig, okay? So all the identities that were on a 30-1 formula sheet, you will still have access to, because we are just that nice a human race, us math teachers. So 1 minus cos squared x is sine squared x. So that can be now written as the limit of sine squared x over x squared as x approaches 0. Now, what does sine squared x mean? Well, sine squared x means sine x, or sine x times sine x. And the x on the bottom means x times x. So I can actually now break that up to be sine x over x times sine x over x. Now, I know that the limit of sine x over x is 1. And so this actually becomes 1 times 1. And so my answer is 1. Now, here's my official warning about the specificity of your communication. There will be profs out there that will not allow you, oh, I don't like orange on orange, sorry. There will be profs out there that don't allow you to go from there directly to there. Rather, they're going to want to see that that's the limit of sine x over x times the limit of sine x over x. They're going to want to see that as 2 limits first, so that then you write it as 1 times 1 and then get it as 1. Okay, so again, this is just me giving you a friendly warning. Certain profs are more concerned about communication than other profs. Okay. All right. Okay, so let's try. The limit as x approaches 0 of cos x minus 1 over x. Now, again, I can't do anything with cos x minus 1. So why not ultimately try and change that to sine? Well, to try and change it to sine, I actually need to multiply by, I don't know if you are thinking this through yet or not, but I have to multiply by the conjugate of the numerator there. If I took cos x minus 1 and I multiplied it by cos x plus 1, I get cos squared x minus 1. And cos squared x minus 1 is sine squared x. So that's going to get me where I want to go. Okay, so here I go. I multiplied it by cos x plus 1 over cos x plus 1. That gives me cos x squared minus 1 on top, which I can now change to be negative sine squared x. Okay, a reminder, I neglected to talk to you about that negative there. So let's just have that conversation really, really quick. The Pythagorean theorem is sine squared x plus cos squared x equals 1, right? So if I have cos squared x minus 1, that means I brought this guy over here and I brought that guy over here. So that's where that becomes negative sine squared x. Okay. Okay. So now what do I do? Well, I can say that this is sine x over x times negative sine x over cos x plus 1. Okay, all I did there was I broke my sine x right here into sine, sorry, I broke my sine squared x into sine x times sine x. I put one of them with the x because this is friendly to me. I know what to do with that guy, right? I know that the limit as x approaches 0 of sine x over x is just 1. But now I have to deal with this, okay? So how am I going to deal with that? Well, I know that the limit of negative sine x as x approaches 0 is 0. That was one of the very first things I did. Okay, that was one of the very first limits we talked about. The limit of sine x as x approaches 0 is 0. So negative 0 is just 0, right? The limit of cos x as x approaches 0 was 1. And so I changed my sine x to be my 0, and I changed my cos x to be my 1. So that gives me 1 times 0 over 1 plus 1, which is just 0. I do need to see, this is important to me in my communication, right? Okay, so just be careful that you show that to me. All right, take my ink off there. Let's take a look at this guy. The limit of sine x over pi minus x as x approaches pi. Well, as x approaches pi, I first would kind of like to have this say x minus pi instead of pi minus x. So to do that, all I have to do is factor out a negative 1. So the first thing I'm going to do is factor out a negative 1. And then that would leave me with negative sine x over x minus pi. Okay. The reason I did that was because the other thing I did was, do you see over here, I just moved my pi here. Okay, and then that left me with x minus pi is approaching 0. So now I can look at this and say this whole thing is approaching 0. That's why I rearranged this. It's going to be a little friendlier to me. Okay. Cool. But now I don't know anything about negative sine x. But then I've got this x minus pi on the bottom, and I think through that x minus pi, and I think back to 30-1, and I think, is there anything I've ever done with x minus pi, or really two measures subtracting from each other? Is there anything I've ever done with that and with sine? Well, it would be nice to think through what sine of x minus pi is. Wouldn't it be nice? Think about this for a sec, okay? Just a little sidebar here. You know that sine of x over x, the limit of that as x approaches 0 is 1. So if I now have rewritten this guy as x minus pi approaches 0, and I've got x minus pi on the bottom, then wouldn't it be fantastic if I could write sine of x minus pi over x minus pi? Isn't that essentially in the same format as this? So the limit of that as it approaches 0, as x minus pi approaches 0, would be 1. Okay, well, that's all a lovely, lofty conversation, but I don't know what the sine of x minus pi is. So why don't we do that? Let's figure out what the sine of x minus pi is equal to and see if that's going to help us get to where we need to go. Okay, so that's an identity that's on your 30-1 formula sheet. The sine of x minus pi, the sine of a minus b, is the sine of a cos of b minus cos of a sine of b. So in this case, a was x and b was pi. So it will equal the sine of x cos of pi minus cos of x sine of pi. Okay. Do you know the cos of pi? Well, and do you know the sine of pi? Okay. Remember, Calvary Stampede, cos is your x value, sine is your y value. So if I'm looking at pi on my unit circle, I have an x value of -1 and a y value of 0. So this becomes -1, which means this is negative sine. This becomes 0, which means this whole thing is wiped out, and I have negative sine. Okay. Are you with me where I am? Have you gotten excited yet? Do you see why I'm having this conversation? You just told me that sine of x minus pi is negative sine x. Well, look what we have up top here. We have negative sine x, which means I can now change that to sine of x minus pi, which is exactly what I wanted to do in the first place. It's exactly the, wouldn't it be nice that we just had of a conversation, okay? So I can change, I know some of your heads are hurting. You're gonna get this. This is the hardest one. This is the last example, right? The last example is always the hardest. I can change my negative sine x to be sine of x minus pi. So now I'm looking at the limit as x minus pi approaches 0 of sine of x minus pi over x minus pi. That's the same as saying the limit as x approaches 0 of sine of x over x. So done, it's 1. Yay! Okay, you might want to rewind this one and just listen to these last 30 seconds one more time. Okay, so that's what we're working on today. Okay, just trying to play with these things, understanding that the limit as x approaches 0 of sine of x equals 0. The limit as x approaches 0 of cos of x equals 1. And then the limit as x approaches 0 of sine of x over x equals 1. And then all the things we can do with those 3 items. Okay. All right, so here's your homework. This will get you through the first trig lesson, and I will see you for lesson 2 when you choose to turn me on again. Okay, take care, guys.